post the recordings so that you can watch this later if you want. But feel free to interrupt me and ask questions. Don't think you can't stop me just because we're recording this. So today we're starting section 8.1, which is called Fundamental Trigonometric Identities. This whole chapter is really just about identities and trigonometric equations. This is the full list of trig identities. I would not ask you to memorize these, but I am going to let you use this on the test so that you don't have to take up space on your little formula sheet with these. So keep up with this paper. I think it's just front side, yeah. So we want to keep up with this, so keep it somewhere, like maybe stick it in the front of your folder or something so you don't lose it. It's broken up by section, so you can see we have section 8.1 goes all the way to here where it says Pythagorean identities, then sum and difference identities is section 8.2. 8.3 is double angle, half angle, power reducing, sum to product, and product to sum. And then the rest of this is chapter 9, so we won't be using this bottom part of the formula sheet, so you can just kind of ignore all of this for now. All right, so let's look at these identities that we're going to be using today, just really briefly. We have the reciprocal identities, which you guys already know. I saw a lot of you writing these down on your test. We have these cofunction identities, which I briefly mentioned in chapter 7. This is sort of the extended version where we have cofunction identities for every single one of our 6 basic trig functions. We have the quotient identities, which we learned in chapter 7, that tangent is sine over cosine and cotangent is cosine over sine. Then we have these new period identities. I want to say that this is not used on any of the problems in the homework, so you probably can ignore these. We do use these even and odd identities. So even and odd, that's something that you may have learned in algebra. A function is called even whenever it has certain properties and odd when it has other properties. So that is summarized here. You can see it says that sine of a negative angle, so like say sine of negative 90 degrees is the same thing as negative sine of 90 degrees. So this shows you like how you get a negative outside of the parentheses. And then our last one's very useful are these Pythagorean identities. So if you go on and take calculus, you may have to have some of these memorized. I would say the most useful ones are probably these Pythagorean identities are the ones that you use the most when you get to calculus. And of course the reciprocal identities and quotient identities. I don't even think of those because that's just something you should have memorized. But let's get started. We're going to talk just briefly about what identities are and what they're used for. So identities, I want to say I mentioned this in chapter 7, but identities are equations that are always true. So identities, this is not how you spell it. Identities are equations that are true for all values of the variable. So that means no matter what angle you plug in, that equation is still going to be true. Sorry, let's see if we can get this back in focus. There we go. All right, so identities are equations that are true for all values of the variable. So no matter what you plug in for x or theta or beta, whatever the variable is in that equation, that equation will remain true. Identities are super useful. They are used to simplify complicated trigonometric expressions, which makes it easier to solve equations. All right, so We used trig identities to simplify complicated trig expressions, which makes it easier to solve equations. We'll talk about this whenever we get into section 8.4, which is where we'll start solving equations. But it's easier to solve an equation like this, for example. It's easier to solve an equation like this than it is to solve an equation that's made up of like addition and subtraction. So maybe if you have something like, I don't know, cosine of 2x plus sine squared x equals 0. It's easier to solve whenever you have things being multiplied, because then you can just use what's called the principle of zero products, and you can split them up and set them both equal to 0. So we're going to use identities to take equations that look like this and rewrite them into something that's easier to solve. All right, so today we're just going to be practicing using these basic trig identities. So we want to keep this right beside you so we can keep referring back to it. And you want to keep this beside you when you're doing the homework, for sure. Keep this little identity sheet beside you. All right, so let's start with some simple examples, and then as we go through the examples, we'll move into the more complicated ones. All right, so directions are the same on all of these. So I just kept it as number 1, and then I did parts A, B, C, and I think we go all the way to like maybe K. All right, so simplify the expression cosine theta plus sine theta times tangent theta. Now your goal here is not to like cancel things. You do want to cancel things out, but it's okay if you're left in your answer with something like sine or cosine or secant or cosecant. You're just trying to make this look more simple. So that's what it means by simplify. So just make this expression look more simple. All right, so let's look at our trigonometric functions or expressions that we have here. We have cosine, we have sine, and we have tangent. Now we know from our quotient identity here that we could rewrite tangent as sine over cosine. So let's do that. We're going to use our correct variable here. So it's x's on this little formula sheet. It's thetas in our problem, so we need to use thetas. We're going to leave cosine alone. We're going to leave sine alone. But we're going to rewrite tangent. I'm going to put it in little parentheses here. I'm going to rewrite tangent as sine over cosine. And then you can also, write yourself a little note here. You could write like, quotient identity. So if you want to look back at this later and think like, oh, where did I get that from? You could write that this was one of your quotient identities. So typically with these problems, how it works is it gets worse before it gets better. Right now it already looks worse. Now we have a fraction in here. But we're going to keep trugging along. We're going to combine these two. We have sine theta times sine theta over cosine theta. So you can think of this as being like sine theta over 1. Just multiply numerators, multiply denominators. So this cosine just drops on down. I forgot to put my little equal sign out front. Make sure you have that out front. So equals, leave that first little cosine alone. So cosine plus, multiply numerators, multiply denominators. So this brings us to something really important, some notation that I need to show you guys. Whenever you multiply sine theta times sine theta, that's going to be sine squared theta. So it's sine theta times sine theta, just becomes sine squared. But you want to make sure that you write it correctly. I'm just doing this on a separate sheet of paper so I keep that nice and neat. All right, so let me start that over. Sine theta times sine theta. There's 2 ways to write this. The first way is that you could write sine theta in parentheses all squared. Now that's a lot to write every time. So to make it more simple, the notation that we will use from here forward is we'll do sine and then we'll put the little squared on the sine and then theta. The reason that we do this is because we don't want to just write it as sine theta squared, because this would be where you were squaring the angle and not the trig function. So here, this is like, imagine this is 90 degrees. This would be like sine of 90 degrees squared. So 90 times 90 is 810. So this would be sine of 810 instead of saying sine squared of 90 degrees. So you want to make sure that the squared is on the sine and not on the angle, so don't do this. All right, so this is the notation that we will use for cosine or sine or any trig function raised to a power. So we always write the little exponent on the trig function. All right, so sine times sine is sine squared. So sine squared theta. 1 times cosine is just cosine theta. All right, so now we need to get a common denominator. So you imagine that this is over 1. Our common denominator, our least common denominator here would be cosine theta. So our LCD would be cosine theta. So we're going to multiply this denominator over here by cosine theta to make it the same. And whatever we do to the bottom, you also have to do to the top. So multiply the top by cosine theta as well. All right, so then we have cosine theta times cosine theta, that's cosine squared theta. So cosine squared theta all over 1 times cosine is cosine plus, this is staying the same. We weren't missing anything out of our common denominator over here, so we're just going to copy that down. Sine squared theta over cosine theta. Okay. Now that we have the same denominator, we can just add the top. Denominator stays the same. All right, so add the top. Denominator stays the same. And then this guy up here, I know some of y'all might recognize this because I saw some of y'all trying to use it on the last test, the Pythagorean identities. So if you look at your Pythagorean identity down here, sine squared theta plus cosine squared theta, or in this case, or it says x is on ours, but I'm using thetas because that's what's in our problem. In our case, we just have cosine squared theta plus sine squared theta. It's just written, backwards. That's fine. So that numerator is going to simplify to 1. All right, so numerator up here becomes 1. We can write ourselves a little note here. This is a Pythagorean identity. All right, so that numerator becomes 1. And we have 1 over cosine theta, which is one of our reciprocal identities. What's 1 over cosine? Secant. Yep, so that's secant theta. This was a reciprocal identity.
So that would be your answer.
Yep, that's right. Once you get it, you want it to look as simple as possible. So it looks pretty simple here when we get to 1 over cosine theta, but there is another trig expression that can make that look, or trig identity that can make it look even more simple, which was that reciprocal identity. So you just want to make it look as simple as possible. All right, so that's where we would stop here. You can't get any more simple than that. So you just have a trig function. It's raised to the first power. Nothing crazy is going on with our angle theta. So that's how you know when to stop, is when you get to something that looks so simple that you could not get any more simple than that. So typically your end result in this section anyway would be something like this, like secant or maybe cosecant. You could have like 1 or -1. Sometimes you'll end up with those. And I want to say there may be a couple where you end up with something like sine squared x or sine squared theta. So that's about as complicated as your final result should be, is a trig function squared. All right, so let's look at this next one. We have cotangent beta times secant beta. So you just look at your two trig functions. We have cotangent and secant. You try to think, okay, how can I relate those two? We know that cotangent could be written as cosine over sine, and secant could be written as 1 over cosine. So I just used my quotient identity here, and then I also used my reciprocal identity up here at the top. So I could rewrite cotangent as cosine over sine. So cosine beta over sine beta. Just be careful, make sure you're not losing your angles whenever you write these identities or replace these expressions with their identities. And then we said that secant could be written as 1 over cosine. All right, so that's 1 over cosine beta. We're multiplying two fractions, so we are allowed to cancel diagonally or up and down. We could cancel out the cosines here, right? So we got 1 cosine in the top, 1 cosine in the bottom. So you just cancel those guys. This is something that happens a lot. You'll see, you know, two fractions, and you could cancel out the denominator with something in the numerator. All right, so that leaves you with a 1 in the top, sine beta in the bottom. So 1 over sine beta. And what's 1 over sine? Cosecant, yeah. So cosecant beta. So I used this right here. This was a quotient identity. This was a reciprocal identity. And then I used another reciprocal identity. And like I said, it doesn't get any more simple than this. This is just a single trig function. There's no exponents. There's nothing crazy going on with my anger. So I know I'm done. Now, you can, you know, use photomath or Wolfram Alpha or whatever to simplify these. It's not going to help you, because whenever we keep moving through these sections, these are the simple ones. So, you know, if you use something to get the answer on these simple ones, it's really not going to help you when we get to the more complicated trig expressions. So I would really suggest, this is probably the hardest stuff that we've done so far, so I would really suggest that you, you know, take time and work through these. You're not always going to be able to immediately come up with which identities to use, but you could always email me and say, hey, could you give me a hint on how to get started here? And I'm happy to help you. All right, last one on this page. We have a negative angle. So anytime you see a negative angle, you're going to immediately know, okay, I'm going to have to use one of these even-odd identities. Where are they? Right here. All right, so make yourself a note maybe here that says, like, negative angles. You never want a negative angle in your final answer. So this is, use those identities for negative angles. You never want to leave a negative angle in your final answer. All right, so our trig function here with a negative angle is cotangent. So we have cotangent of negative theta times tangent theta. Now already I can, you know, think in my head, okay, well, cotangent and tangent, those are reciprocals of each other, so I may have to use something to do with that. But let's take care of that negative angle first. All right, so cotangent of negative x, right here it says cotangent of negative x is negative cotangent x, so the negatives can just pop outside. All right, so we're going to rewrite that as negative cotangent theta times tangent theta. All right, so make sure you keep that negative out front, don't lose it. Now, like I said, cotangent and tangent are reciprocals, so we could rewrite cotangent as 1 over tangent. Keep that negative out front. All right, again, we can pretend like this is tangent over 1. Tangent in the top cancels with tangent in the bottom. So cancel those tangents. You're left with, don't forget your negative out here. So negative 1 in the top, 1 in the bottom. So 1 over 1 is just 1. It definitely can't get any more simple than that. So once you get to something like a number, then you know you're definitely done. All right, so that's right here. We used an even/odd identity. And again, you don't have to do this part where I'm writing out which one I used. You don't have to write that down on the test or anything like that. This is just, if you look back at this later, I want you to know where each part came from. And then we have a reciprocal identity. These are some of my favorite problems in Trig. What do y'all think? Do y'all like them so far, or you hate them? Yeah, I think the hardest part probably about them is you just don't know when you're done. There's no good way to know when you're done. It just takes practice. And you'll start seeing patterns, and you'll say, okay, I know that I'm done because I have something really simple, like just a regular old trig function in my answer, or just a number in my answer. So that's probably the hardest part, is knowing when to stop. All right, so we're getting a little bit more complicated on this next one. We got a fraction. We're starting with a fraction. All right, so we have part D is 1 over cotangent squared theta plus 1. Anytime you see something squared plus 1, or, say a trig function squared plus another trig function squared, that should make you think Pythagorean identity. So since I see this trig functions being squared and I have a 1 out here, that's making me think Pythagorean identity. So I'm going to look over here. So here I see 1 plus cotangent squared x. Same thing I have in my denominator. So I can replace my denominator with, cosecant squared theta. So we're going to replace our denominator with cosecant squared theta. All right, so that's 1 over cosecant squared theta. Now, I wanted to take a second today and talk about the parentheses around the angle. Whenever you have something simple in your angle here, like theta, you don't have to put parentheses around it. It's totally your preference. There are some cases where you have to put parentheses around your angle, and so I just wanted to show you some examples of that before we just move on real quick. If you had something like, let's say, theta plus, 2, that would have to be in parentheses. If you have any kind of addition and subtraction going on within your angle, you have to put it in parentheses. It's even okay if you have something like sine of 2 theta. It's okay to not put it in parentheses. Your homework sort of goes back and forth. Sometimes they put it in parentheses, sometimes they don't. So don't think that when you see the parentheses that means anything special. They'll write sine with a parentheses theta, and sometimes they'll write sine theta. Those mean the same thing. So don't stress over the parentheses right now. We really get into the parentheses when we get to like product to sum and sum to product identities, which is in section 8.3. So we'll have plenty of time to talk about when do I do parentheses, when do I not have to worry about parentheses. All right, so back to our problem. Let's look at what we have going on here. This is pretty simple. We're not terribly far from the answer. Ignore this little squared for a second. I'm going to just try to cover it up with my pen. What's 1 over cosecant? Sine. Good. So if I have 1 over cosecant squared, that's sine squared. And I'm just trying to keep it like consistent. Like if they use parentheses, I'm using parentheses. So you don't have to put parentheses around the theta here. It's not incorrect if you take them off. So again, I use the fact that I know that 1 over cosecant theta is sine theta, which means that if I have cosecant squared, all I have to do to correct this is make it 1 over cosecant squared equals sine squared. Okay. And this is as simple as you can get. You could change this. You could use one of your Pythagorean identities. You could move this cosine over or cosine squared over, but that would not be more simple than sine squared theta. So we're going to leave it here. You can't get any more simple than that in this case. And then I'm just going to write a note here that I use a reciprocal identity. So we won't be using the unit circle that much on this test until we get to section 8.4, but I think maybe we will redo the unit circle quiz. That way because some of y'all's were perfect, but then some of y'all's were kind of messy, so I thought it'd probably be beneficial to have one that was a little bit neater. All right, so let's look at this next one. Again, not terribly difficult. I would say we get into the pretty difficult ones here on part F, but this one is not too bad. We have tangent beta over sine beta. And remember, this is like tangent of beta, sine of beta. You're plugging those angles into this trig function. It's not tangent times beta. All right, so what is a identity that could relate tangent to sine? How could we write, oh, sorry, I interrupted you. What did you say?
Quotient.
That's right, quotient identity. Very good. So you are going to change tangent to sine over cosine. So that's one of your quotient identities. Some of these you'll have memorized by the time we get to the test. This will probably be one of them. So we'll do sine of beta over cosine of beta all over our denominator was sine beta. Right, so that was a quotient identity. All right. Now we'll just do algebra from here on out, and then I think we have to use one more trig identity maybe. So we're going to keep, change, flip. I saw y'all doing that on the test, so I know you know how to do it. Keep, change, flip. Keep the top fraction the same. Change the operation to multiplication and then flip that bottom fraction. You can pretend like that's sine over 1, if that helps you when you go to flip it. All right, so keep the top one the same, sine beta over cosine beta. Change the operation to multiplication. Flip the second one, so 1 over sine beta. Sorry, my angles are getting a little bit messy. All right, what should we do now? Very good, cancel signs. We got a sign in the top and a sign in the bottom, so cancel the signs. All right, and we got a 1 left in the top, we got a cosine left in the bottom, so that's 1 over cosine beta. What's 1 over cosine? Secant. Very good. And again, you can't get any more simple than this. It's just a regular old trig function. So we're done. Be careful with the angles, like if they start off with a theta, they're going to want a theta in the answer. You know, keep the angles the same. It should give you like a little warning, like if you type in, say here we typed in like a theta, it would say this is a character that's not used in your answer. It should say something like that. All right, so this was pretty much, yeah, I would say this is the end of the simple ones. Now we're moving into the more difficult ones. Here we have part F is cosecant squared theta minus cosecant squared theta times secant squared theta. All right, so I want to change this to something that I think will probably look a little bit easier to you. All right, so imagine you had something like this, x minus x times y. You would say, this is like going back to algebra, you would say, okay, I have an x here, I have an x here, so I'm going to factor out an x. So you would pull out an x out front, and what would be left in the parentheses?
1.
1, because x divided by x is 1, minus, and then what's left here? Y. Good. We're going to do the same thing in this problem. All right, so you pull out an x, so you're dividing everything by x, so x comes out front, x divided by x is 1, xy divided by x is y. All right, so we're going to do the same thing here. We have a cosecant squared theta here and another cosecant squared theta here. So that cosecant squared theta is going to get pulled out front. Draw your little parentheses. Give yourself plenty of room in there. Do equal signs before we forget. All right, so let's think about what's left over. This is going to cancel out. So cosecant squared theta over cosecant squared theta is just 1. Minus the cosecant squared theta cancels out, and you're just left with secant squared theta. All right, now you'll have to be kind of careful here and write this neatly, because on the next few problems, I want to say you've got these like double parentheses. So just make sure you're making, one set of parentheses bigger so that it doesn't get all jumbled up. All right, so what I just did is exactly the same thing as this. So I had cosecant squared theta minus cosecant squared theta times secant squared theta. Same thing as this. I just replaced cosecant squared theta with x, secant squared theta with y. I pulled out my common factor and then simplified. All right, so now remember, just ignore this for a second. Remember I told you guys a few minutes ago, anytime you see like a trig function squared and a 1, that should make you think Pythagorean identity. All right, so let's look at our Pythagorean identities. We have 1 minus secant squared theta, sort of similar to this middle one here. We'll just have to do some algebraic rearrangement. So let's write that down over here off to the side. Let's go off to the side and write that Pythagorean identity. So it's tangent squared x plus 1 equals secant squared x. Now we need it to be 1 minus secant squared theta, or secant squared x in this case. So in order for us to get that, we can move this secant squared over to the left-hand side. All right, so let's move that over. Move over the secant squared x, subtract it from both sides. It's going to cancel out on the right. Cancel, cancel. All right, that leaves you with tangent squared x plus 1 minus secant squared x equals 0 on the right-hand side now. Almost done. This is what we want. We want just that 1 minus secant squared x. So let's move this to the other side. So let's move that tangent over. So minus tangent squared x minus tangent squared x. Cancel, cancel. So we have 1 minus secant squared x equals negative tangent squared x. All right, so that's what we wanted. We wanted to know how could we simplify 1 minus secant squared. So now we know that 1 minus secant squared theta is going to simplify to negative tangent squared theta. All right, so let's replace this inside here. All right, so keep that first part the same. Inside simplifies to negative tangent squared theta. Again, you got these double parentheses. So just keep your notation neat. Make the outside parentheses kind of bigger. All right, so that was a lot of work for our first step. I guess really it was the second step because we had to factor out a cosecant first. We're working towards the end here. Now we got to think, okay, how could we relate cosecant, which we know is 1 over sine, how could we relate that to tangent? What would we have to do to this tangent? Something with sine. Yep, sine over cosine. So let's change this tangent squared theta to sine squared theta over cosine squared theta. And then we're going to go ahead and change this one as well. We know that cosecant is the same thing as 1 over sine. Right, so that becomes 1 over sine squared theta. That was a reciprocal identity. And then in here, just keeping this in parentheses because I got this negative here. I don't want to like drop the parentheses and then think it's a minus. So this is still multiplication. So we got tangent squared is going to be, first of all, don't forget the negative. Tangent squared is sine squared theta over cosine squared theta. Again, that was one of our quotient identities. So I'm just going to write the note here. This was a reciprocal identity. Reciprocal identity. This was a quotient identity. Okay. Now you'll go ahead and cancel those signs. Sign on the top, sign on the bottom. So sine squared cancels with sine squared. Okay. So important to keep your work neat here, especially if you want to like go back and look at your notes later. Because if you don't have neat work, if you don't write yourself notes, it's going to get easy to get lost in what you did. All right, so -1 in the top. In the bottom, we have cosine squared beta. Okay. And what's 1 over cosine? Secant. So that's negative secant squared theta. All right, so I'm going to write another note here. That was the reciprocal identity. So which identities do you see us using over and over? Yep, reciprocal and quotient. You will use those over and over in almost every problem, especially in this first section. So if you don't know what to do, it's good to try to either do a reciprocal identity or a quotient identity if you don't know where to start. I got to get my phone because I can't see the time with this thing up. All right, we got plenty of time. Okay. This next one is sort of similar to our last one. And I say that because you can see we have a cosine here and a cosine here. So we're going to have to pull out a cosine. So just like we did with that cosecant, we're going to factor it out. It's going to come out front. So the cosine x is going to come out front. Then write your little parentheses. And then we'll write what's left over. Big set of parentheses here. So cosine x plus cosine x times tangent squared x. All right, so if we factor out a cosine, what's left in this first term? 1. Good. Y'all are doing so good. And then if we pull out a cosine, that's going to cancel out with that cosine. You're just left with tangent squared x. Okay, so ignore this. Ignore this first part for a second. Whenever we see a trig identity or trig function being squared and a 1, what do we think of? Pythagorean identities. All right, so we'll look at our sheet, look at the Pythagorean identities. 1 plus tangent. All right, there's 1 plus tangent squared x. All right, so 1 plus tangent squared x is secant squared x. All right, so 1 plus tangent squared x changes to secant squared x. All right, so cosine x inside changes to secant squared x. We don't have any negatives on this one, so you could go ahead and drop that outside set of parentheses here. Let's write a note. This was Pythagorean identity. All right, so I'm going to drop this set of parentheses, if you don't mind. And then I'm going to think, how can I relate cosine and secant?
1 over secant.
Yep, 1 over secant. So cosine is the same thing as 1 over secant. 1 over secant of x. Be careful there because sometimes your C ends up looking like a parentheses. I'm going to write this as secant squared x over 1. That way it'll help me cancel. So secant cancels with one of these secants here. So this secant cancels with one of these secants. That knocks it down to just a regular old secant. So not secant squared anymore. All right, so 1 times secant x in the top gives me secant x. Canceled out everything in the bottom. This was just a 1. This is a 1, so I don't have to worry about my denominator. And this is as simple as you can get, so we can stop here. All right, so let me write here. This was a reciprocal identity. All right, so another approach you could have done here is you could, very similar, you could have changed secant squared x to 1 over cosine squared x. You would have ended up with the same thing, but this is faster. So changing cosine to match the secant ended up working out faster for us here. So this was perfect. Y'all are doing such a good job. This is really hard. So I appreciate your concentration and attention. All right, next one. First thing I see here when I look at this is that negative angle. So I know I'm going to have to use an even-odd identity. So I have 1 over cotangent alpha. This is the Greek letter alpha. So 1 over cotangent alpha times secant of negative alpha. So let's look at our even-odd identities for secant. All right, so we have secant is an even function, which means that secant of negative x is the same thing as secant of x. So the negative just goes away. So this is like saying secant of negative 90 degrees is the same thing as secant of 90 degrees. So they're equal. So we can change secant of negative alpha to just secant alpha. So let's do that. 1 over that cotangent alpha stays the same. Alpha kind of looks like a fish swimming to the left. And then we have secant of alpha. And again, that was our even-odd identity. That's the first thing you want to take care of anytime you see a negative angle. Okay, now we're thinking, how could we relate cotangent, which is cosine over sine, with secant? Yep, that's right. Cosine is 1 over secant. And then you could also write secant as 1 over cosine. So we're going to rewrite cotangent. Make sure you do 1 over. We're going to rewrite cotangent as cosine theta over sine theta. That's one of our quotient identities. You can put it in like a big set of parentheses if you want to. I think I'm just going to do like a little times here. And then we know that secant, it's one of those reciprocal functions, that's 1 over cosine alpha. So what can we do now? Cancel cosines. One's in the top, one's in the bottom. All right, so still 1 over. So 1 over. In this little fraction in the bottom, we have just a 1 left in the top, sine left in the bottom, so that's 1 over sine alpha. Now we gotta keep, change, flip, or multiply by the reciprocal, same thing. Keep, change, flip. I'll go back and write which identities I used at the end. All right, so keep the top the same. Change the operation to multiplication, flip that bottom fraction, so that's sine alpha over 1. So 1 times sine of alpha is just sine of alpha. Your turn. Again, the whole purpose of this is simplifying these so that whenever we get to the solving equations part, we can take something complicated like this fraction and we could rewrite it as just sine alpha, which is much easier to solve. You know, you would look on the unit circle and figure out, okay, like where is sine alpha equal to 30 degrees or pi over 4 or whatever. So this is much easier to work with compared to this big fraction. All right, so I'm going to just write in here which identities I used. This was a quotient function. Quotient identity. I'm going to get it right eventually. And this was a reciprocal identity. All right, so again, using those same 2 over and over. If you don't know where to start, it's always a good idea to try to use a quotient identity or reciprocal identity. All right, next one. This one's pretty complicated. We got some fractions. We've got this weird stuff happening over here. So we have 1 over cosecant squared beta plus cosine beta times sine of pi over 2 minus beta. Anytime you see pi over 2 minus an angle, that should make you think cofunction. So if you see pi over 2 minus an angle, that's a cofunction identity. So we're looking for sine of pi over 2 minus an angle.
Would that maybe negative? Minus 7?
That's a good question. So if it was just this, then you would do the even odd identity. But since it's got that pi over 2 in the front, then that you don't have to use the even odd identity there. You can just look straight at, where are they? Here. All right, so we're looking for the one that has sine of pi over 2 minus an angle. I wanted to try turning this lamp off and see if that looks better. Okay, there we go. I feel like that looks better. I don't know. All right, so sine of pi over 2 minus an angle. We have actually two options. I guess we'll use whichever one we think will benefit us more. So sine of pi over 2 minus beta, we could either use this one or this one. All right, so we want to use this first one because we have a cosine right beside it. So we're going to change sine of pi over 2 minus beta to cosine beta. All right, so that's going to change to cosine beta. This part here. That whole thing changes to cosine beta. Just rewriting this, we have 1 over cosecant squared beta plus cosine beta times sine of pi over 2 minus beta becomes cosine beta. That's times there. All right, cosine times cosine is cosine squared. All right, so keep that first part the same. We just keep bringing it down. We'll deal with it in just a second. So cosine times cosine is cosine squared beta. I guess I'll keep it in parentheses so it'll sort of match that first one. Sorry, that looks super messy. That's a 2 there. All right, so again, just want to remind you, we put the squared on the trig function, not on the angle. So make sure you're putting the little squared on the trig function. 1 over cosecant is the same thing as what? Sine. So that changes to sine squared beta, since it was cosecant squared. I still need to go back and write which trig identities I was using. And remember what we said, if you see trig functions being squared, you should think Pythagorean identity. What's sine squared beta plus cosine squared beta? According to our Pythagorean identity. 1. Very good. You're done. Can't get more simple than that. All right, so let me go back in here and write what I was using. This was a cofunction. I don't really like the cofunction identities. Not that there's anything wrong with them. I just don't find them to be as useful. So you probably wouldn't see one of these on the test. But you will see them on the homework. Then here, we just multiplied those. That wasn't an identity. Here we did use a reciprocal identity. All right, so again, probably not going to see something like this on the test. We have to use one of these cofunction identities. I just think there's more important identities to cover on the test. But definitely should see something like this on the homework. All right, we only have 2 more left. They're doing such a good job. This sort of looks like, whoops, sorry, you couldn't see what I had on there. This sort of looks like something that we did earlier today. Sort of like this, where we had factored out a cosecant. It's already factored out for us. So we're just going to, I think I'm going to start inside the parentheses and try to simplify inside of this parentheses as much as possible. So I have cosecant and sine. How could I rewrite cosecant in terms of sine? Yeah, Good. 1 over sine. All right, so leave this cosecant out front alone. Just drop it down. So cosecant theta out front. Inside, we're going to change that to 1 over sine theta minus sine of theta. I'm just going to write here that was a reciprocal identity. We have a fraction minus, we could make this into a fraction also, just put it over 1. So let's get a least common denominator in here and combine those. So LCD, super simple here. It's just going to be sine theta since this one is just 1. So LCD is going to be sine of theta. So ignore this cosecant out front for a minute. So just sort of cover it up. Don't think about it. We're just working on the parentheses right now. All right, so we're going to multiply the denominator over here times sine theta. Whatever we do to the bottom, you also have to do to the top. So multiply times sine theta on the top. All right, so just drop down this cosecant out front. Big parentheses. All right, I'm going to add in this extra step where I'm going to just write out my two terms with the common denominator. Sine times sine is sine squared. So I'm seeing this and I'm already kind of thinking, okay, we might be headed somewhere where we need to use a Pythagorean identity. 1 times sine is just sine. Denominators are the same now, so we're just going to subtract the top. Denominator stays the same. So just drop down that cosecant out front again. Big parentheses. 1 minus sine squared theta in the top. Denominator stays the same, so that's sine theta. Okay. I see a couple of ways that we could proceed from here. I'm not sure what the best way to go is. So I'll just tell you, if I was doing this on my own, I would say, okay, well, this looks like something I could use a Pythagorean identity on. So I'm going to just look at my Pythagorean identities. So this is the one on the left is the one that involves sine. So I'm going to have to do a little bit of rearranging here. I need it to be in the form 1 minus sine squared. So I would subtract this sine squared x to the right-hand side, and that would give me, I'll write it over here on the side. So if I had sine squared x plus cosine squared x equals 1, I could subtract sine squared x. That would give me cosine squared x equals 1 minus sine squared x. So you'll do a lot of this rearranging of Pythagorean identities too. That's the common technique to use when you're simplifying these. So now we can replace this numerator right here with cosine squared x, or cosine squared theta in our case. All right, so drop down that cosecant out front. We're about to deal with it in just a second. Change the numerator to cosine squared theta. Denominator stays sine theta. Okay. So now let's go ahead and deal with this cosecant out here. We know that cosecant is the same thing as 1 over sine. So that's how I would proceed. I would change that cosecant theta to 1 over sine theta. Big parentheses, cosine squared theta over sine theta. Nothing to cancel here, unfortunately. But we can just go ahead and multiply these fractions together. Multiply numerators, multiply denominators. So 1 times cosine squared theta is just cosine squared theta. And then sine times sine is sine squared. So that's going to be sine squared theta. All right, right, we're almost done. Ignore the squares for a second. What's cosine over sine? Cotangent. So if they both have a squared, that makes it cotangent squared theta. So since they both have a squared, they both are being raised to the same power, that makes it cotangent squared theta. And again, you can't get any more simple than this. You could like try to use the Pythagorean identity, try to simplify it from there, but it wouldn't get any more simple than that. We have one more, and I want you guys to look at this one and see if you see the same thing I see. And by the way, like I said before, I think we were like at this step maybe here, or maybe it was here. There's lots of different ways you can approach these problems. You don't have to do it one certain way. There's no set of rules for how you approach these. It's just, here's these identities. Try to use one, along with like what you know about algebra to simplify these. So what do y'all see when you look at this that stands out? Yeah, cofunction. So we have a angle here. It's pi over 2 minus a beta. So when you see pi over 2 minus something, then you think cofunction. All right, we're looking for cotangent. All right, so here's cotangent right here. Cotangent of pi over 2 minus x. Ours is betas, right? Yeah. So cotangent of pi over 2 minus beta is the same thing as tangent of beta. So let's change that expression here to tangent of beta. So I'm just going to highlight what's getting replaced. So this whole thing right here becomes tangent of beta. All right, so we have everything else going to stay the same for right now. That changes to tangent of beta. Denominator is secant of beta. All right, so that was a cofunction. I need to go back in the last one, I guess, too, and add in which identities I was using. Not reciprocal cofunction. So that was a cofunction identity. All right. Ignore the denominator for right now. Let's just focus on the numerator, simplifying the numerator. Cosecant and tangent. Let's see, we could change cosecant to 1 over sine. And we could change tangent to sine over cosine. So let's do that. All right, so just you're always trying to think of ways that you could relate the trig functions. Cosecant is 1 over sine, so that's 1 over sine beta. Make sure you don't lose your angles. And then I'm going to do a little times. Tangent beta is sine beta over cosine beta. This is nice for us because what's going to happen? The signs are going to cancel. Don't forget that this is all over secant. All over secant beta. All right. Signs are going to cancel. In the top, we're left with 1 in the numerator, cosine beta in the denominator. So that's 1 over cosine beta all over secant beta. We could change secant to 1 over cosine. Yeah. So let's do that. 1 over cosine beta. Then we'll do what? Very good. Cube chain flip. So impressed. Y'all are doing a great job. This is not easy. So 1 over cosine beta, keep that the same, change it to multiplication, flip the bottom fraction, so that becomes cosine beta over 1. Cosines cancel. That's 1 over 1, which is just 1. Anytime you end up with a number, you know you're done. All right, so much easier to work with something like 1 as opposed to this big nasty fraction. So that's why we spend like 3 sections talking about how to simplify stuff with trig identities, because it can make solving equations much easier. All right, so let me stop this recording. And then we'll talk about the test.